In this problem, I want to verify the identity, the sign of the quantity x minus pi over 2 is equal to negative cosine x. So remember, we need to either turn the left-hand side into the right-hand side or vice versa. Well, obviously the left-hand side is more complicated, and I think you can see, hopefully, that this is of the format of the sine of A minus B, the difference of two angles. And so remember, there are formulas for this. So if I go look at the formulas that I have written over here, okay, I think they just fit on. So now I've got to look for the formula that I want. So as you can see, I have the sine of A minus B, so it's going to be this formula here. And so in this case, I have x minus pi over 2. So A is going to be x, B is going to equal my pi over 2. So my identity, the left-hand side is equal to, let's write it out again, the sine of x minus pi over 2. And I'm going to use this formula up here. So it's the sine of x, the cosine of pi over 2. So this is straight substituting into the formula, minus cosine of A is the cosine of x, times the sine of B, which is the sine of pi over 2. So now all I have to do is find what the cosine of pi over 2 is and the sine of pi over 2, and you will find those on your unit circle. So let's see if I can fit my unit circle on here. And remember, on the unit circle, each coordinate, the xy coordinates, instead of being x and y, the x coordinate is the cosine of theta and the y coordinate is the sine of theta. So I need to go up here to pi over 2, 90 degrees, and the cosine of pi over 2 is going to be the x coordinate of 0. So this is the sine of x times 0 minus the cosine of x. I better be careful how I write that. It's the sine of x times 0 minus the cosine of x times the sine of pi over 2. So that is the y coordinate of this point here, so it is 1. So what's my first term? The sine of x times 0, sorry for the bad handwriting, is just 0, minus the cosine of x times 1 is just cosine x. So the answer is negative cosine x. And is that what we were trying to prove up here? That was our right-hand side. So I am done.